Hey everyone, this is Mrs. Bump, and this is your first official homework assignment where you got to take some notes from a video. Today's video is going to be really short and quick, and we're just going to touch upon some of the characteristics that we are learning about today that we didn't have time for. So we're going to add on a few more polynomial characteristics. So when you're in your notebooks and continuing on where we left off in class, you can label this other polynomial characteristics. And I'm losing my headphone there for a second. Sorry, guys. Here are some other things that we can describe about a polynomial without looking at its graph or with looking at its graph. So we could be looking at either the equation or the graph of the polynomial. So first bullet point that we're going to put down here is domain. Now, if you think about all the functions that we've learned about this year that have domain restrictions, polynomials are not on that list. Polynomials like quadratic and linear, they didn't have a domain restriction, and that'll be true for all other polynomials unless for some reason we are giving it one like we did with inverses or working with the real world. Range, however, if you think of what a quadratic graph looks like or a linear graph looks like, sometimes they will have a range restriction and sometimes they won't. So we break that into two categories. If it has an odd degree, like linear or cubics, then the range is going to be negative infinity to positive infinity. No restrictions. The graphs will continue up and down. However, if it has an even degree, it's going to be restricted where the minimum or maximum values are, where the graph kind of has a turning point. Think of like the vertex of a quadratic function. So it's going to either be, depending on if the graph is going up or down, the y minimum, like the lowest y value of that graph to infinity, or if it continues in a downward direction, it's going to be negative infinity until the y maximum, so the highest y value on that graph, which are included, which is why we're using the brackets. There's two bullet points there, so throw some bullet points in there, domain and range. The rest of the notes are going to be with regard to what the degree is going to tell us about our function. So recall from class today, the degree is the highest power, the highest exponent of the polynomial function. So this is about the degree. Okay. So the first thing is it can tell you how many times the graph will turn direction, meaning going from increasing to decreasing or decreasing to increasing. Think about the intervals that we did back in September. So there can be up to one less than the degree turning points. Up to one less than the degree turns. In the general form, the degree is the n, so this is going to be known as n minus 1. Now I'm saying up to because not all polynomials have to turn that many times, but it can be up to that many times. For example, if n was equal to 3, there could be up to 2 turns. So a cubic could turn up to 2 times or less. Quartics, degree of 4, can turn up to 3 times or less. So if the degree is 4, up to 3 turns. Some quartics, however, though, will look like quadratics and will only turn once. So it really just depends on the specific one, but it can't turn more than one less than the degree. Now these turns, when it goes from increasing to decreasing or decreasing to increasing, are known as, or going to be referred to as either local minimums, local maximums. So turns are referred to as, there's a couple of vocab words here. Local min or max. So I could be referring to those minimum or maximum values of the graph. There could be more than one, depending on how many turns there are. You might also hear the vocabulary of extrema. okay, the extrema of the graph, that is still, again, referring to the min or max values. So that's just some other vocab that you might hear. Oh, wait, sorry, got one of them. The other one is relative minimum or max. Now, if you hear the phrase absolute maximum or minimum, that means it's the absolute lowest or the absolute highest point on the graph, and those will be the numbers you would use for range when you're determining the range of an even degree polynomial. Okay, next thing that the degree is going to tell us is how many zeros the function has. Zeros, again, the x-intercepts. We did an activity today in class where we drew the